Good morning. This is your stats sensei, Mr. Spensei, and this is Death Packet questions, problems 1 through 10. This is for Unit 2, displaying and describing data. Data are collected on the 35 students in a college history course. Which of the following is not a variable for the data set? So a variable is something that can vary. In here, we have student birth month, and obviously that can change depending on which student. Each student will have a different one. Political affiliation, that can change. Student age, that's going to vary by student. Each student will have a different one. Student address, then that will vary. The number of students in the data set, that is the sample size. Sample size is not considered a variable. So our answer to the first one is E because it's not a variable. It is a sample set size and it's fixed based on the size of our data set. A local ice cream shop sells ice cream cones for $2 and customers can choose from the following options. You can choose ice cream flavor, type of cone, chocolate dip for an additional 50 cents, sprinkles for an additional 50 cents. Which of the following is a quantitative variable? Well, flavor is qualitative or categorical. Type of cone, qualitative or categorical. So I'm going to put C by these because they're categorical. Chocolate dipped or not, that's also categorical. Sprinkles or not, that's categorical. It either is or not. The cost of the cone, that is measured. And if it's measured, that makes it quantitative. So E, because it's measured, it's quantitative. Which of the following variables for data about a track team is a discrete variable? Discrete means it's a whole number variable. It cannot take on decimals and fractional answers. The height of a team member, well, obviously that can be decimal. So that's not it. That's false. The weight of a team member, false, because that can be decimals. The number of times that a team member finished first, ooh, that's counting. And because that's counting, that could be our answer. That could be that's because that's counting. That's gonna be whole numbers. That sounds like that's probably gonna be it. We'll put a question mark by it till we answer, look at the other ones. The time recorded. Time can always be a decimal, so that's false. That's not it. And the time recorded for a 1 mile race. Well, that's false. So our best answer is C. Matter of fact, that is the only answer in this case that works because it's a whole number answer and discrete is whole number, whereas decimals are continuous. The following dot plot shows the number of strokes taken by 20 professional golfers competing on an 18-hole course. Which of the following best describes the type of variable represented in the dot plot? Well, first off, I'm looking at it and I go, hey, you know what? They can only be whole numbers, so definitely going to be discrete. All right. And we're talking about number of strokes. So we're talking about number, we're talking about quantitative. So quantitative and discrete looks like that's probably my best. It's not continuous because they're whole numbers. It is discrete, but it's not categorical because it's the number of strokes. And order does matter because 64, they do need to be in order. And it's not continuous, not categorical. All right, our only choice is A. So 4 is A. Number 5, the traffic engineer for a large city is conducting a study on traffic flow at a certain intersection near the city administration building. The engineer will collect data on different variables related to the intersection each day for 10 days. One of the following variables, which will be measured by using continuous data. In other words, decimal data. Well, the number of cars. Well, hopefully the number of cars, hopefully there's no fractional car, there's no decimal car or part of a car. So that's not going to be it. The number of pedestrians crossing, unless we hit one and decapitate, not going to be part. The number of bicyclists, same thing as the one above, is still a whole number. Those are all discrete thus far. The number of food trucks. The number of food trucks is also going to be discrete because it's going to be a whole or fixed a whole number. The number of minutes. Time is continuous. So consequently, it can take on decimal answers. Which of the following describes a continuous variable? All right. The number of items sold. Well, we're selling items. Hopefully, we're not selling part items. If we're selling part items, that's possible, but if it's whole items, that's not. The number of apps. Either you download a whole app or you don't. So that's discrete. Both of these are discrete because they're whole numbers. The diameters of tree trunks. Well, tree trunks can be continuous because it's a measurement. Measurements can be continuous. So right now, this sounds like that's our best choice. The number of baskets, obviously that is a whole number. So that's discrete. The shoe sizes. Shoe sizes are also discrete. They don't take on decimals. Actually, I guess you can get half sizes, but it's still discrete. So our best answer to this one is C. Which of the following questions about cars in a school parking lot will allow for the collection of a set of categorical data? All right. So we have a couple words in here. Categorical data, that means it's non-numerical. And I see how many blue cars are in the lot. Well, that's a good possibility, but it says will allow for the collection of a set. And here we only have one, so I don't really like this one, but we'll mark it as possible because it is categorical, but it doesn't sound like a set. What are the gas mileages? Well, gas mileage is going to be quantitative, so that's not right because it's numerical. What are the weights? Weights is quantitative, so that's not categorical, it's numerical. What are the number of cars in a lot without of state license plates? Maybe I kind of like that, but we're talking about numbers, so that still tends to be quantitative. All right. And then what are the colors of the cars? Oh, here we're definitely, so these A and D are possible answers, but the best answer is E because we're keeping up with a set of categorical data. These are definitely categorized based on their colors. All right. So while A and D are possible, the best answer here would be E. All right, number 8. A study was conducted on 3 types of home siding and the type of damage done to the siding by woodpeckers. Each hole made by a woodpecker was classified as either drumming, in other words, it was territorial, foresting, looking for food. I'm surprised that doesn't say foraging, or nesting. The following bar chart shows the relative frequency of the holes for each type. All right, and it's kind of difficult to see this, but right here we have a color differential. All right, so there's a color differential here, the color differential here. So I'm going to mark those because they don't show up very well. All right, so which of the following statements is supported by the chart? And by the way, notice this is a relative frequency chart. So we're working with percentages, we're working with proportions, we're not working with actual numbers. So we need to be careful about any of the ones that talk about the number. Not saying it can't be, but it's unlikely. So the proportion of holes created for drumming is the same for all 3 siding types. Well, we can obviously see that the drumming, the light one, that proportion changes for each one. So that's false. It can't be that. The next one, the proportion of holes created for drumming is greatest for grooved plywood. Well, the proportion here is definitely larger for Norwood. All right. It's probably smallest for grooved. The proportion of holes created for drumming is least for grooved plywood. And I can look at that and go, gosh, that light shaded is definitely less than this and definitely less than clapboard. C is my best answer. The number of holes created for drumming is least for grooved plywood. No, we don't know how, can't talk about the numbers because we don't know if we have a lot of grooved plywood or a little bit of grooved plywood. So we can't talk about the number. The number of holes created for drumming is greatest for non-wood. Once again, we can't talk about that because we don't know how many are non-wood. We can't do that because we don't know the actual numbers in each category. All right, moving on to number 9. So number 9, the following bar chart displays the relative frequency of responses of students by grade level when asked, do you volunteer in a community service? All right. So when I'm looking at this, first off, I'm sitting there, you know what? This is about 60%. This looks like this is 70%. This looks like this is 70%. And this here looks like it's about 50%. So we're going to label that 50% for the 12th graders. Which of the following statements is not supported? I'm going to tell you, if they ask for something that says not, you definitely want to use what I call the true false method, which we label T and F all the way down, and then select the one that only occurred once. So more than 60% of both 10th graders and 11th graders responded yes. Well, I look at it and go, that's 70%, that's 70% for the 10th graders. That's a true statement. 12th grade students had the least percentage of students respond yes. It was like, yeah, they're at 50%. They definitely had the least percentage. Less than 40% of 10th grade students responded no. Well, if this is 70%, that means 30% said no. So yes, that's also true. The number of 10th grade students who responded yes was greater than the number of 9th grade students. I don't know how many 10th grade students there are. I don't know how many 9th grade. The key word is number. The proportion, that's true, but we don't know about the number, so I can't say that's true. So that's false. That must be my answer. All right. 10, a group of first grade students were asked to name their favorite color. The responses are shown in the frequency table. So when the question is, which of the following statements is supported by the frequency tables? More students chose purple. Well, no, the more students chose blue, so that's not it. Twice as many chose blue as chose red. Well, if I double that, 2 times 15 is 30. That's possible. That's exactly twice as many, so that looks pretty good. All right. Yellow was chosen by the least number of students, and it's like, no, green was chosen by the least number. The total number of students is 80. I haven't added these up yet, so I apologize for that. And my calculator is not showing up very well. We'll see if I can fix that a bit. Well, I can't real quickly, so I'm going to just add these up by hand. So 15 and 25 is 40, plus 30 is 70. Plus 12 more is 82. It looks like 90, not 80. So this is wrong because it's supposed to be 90. And the combined number of students who chose green and yellow is greater than the number who chose purple. Well, green and yellow, that sums to 20, and 20 is less than 25, so that's not true. The only possible answer is B. All right, this was problems 1 through 10 of the death packet. Hope to see you on the next one when I go through problems 11 through 20. Thank you.